Good afternoon, everyone.
Wow. Good
Good afternoon, guys. How are you?
Good, thank
Great.
you. How are you, sir?
Good, sir.
Yeah, good. Thank you. Okay. Let me see. Because this presentation. Let me see. How can I solve this presentation problem? Okay. Okay. Good afternoon, guys. Again, thank you for attending this session. I believe you can see my my screen.
Yes.
Yes, we can.
Yeah. Okay. Great.
Yes.
Thank you. Okay. Okay. Let's start. Oh. Okay. First of all, a few notices. Someone, I believe someone will ask about the tutorial changes. I fully understand. Someone said I have this reason or that reason. That's fine, right? If we can support, definitely we will support. So as we mentioned last week, first of all, if you want to change your tutorial time, you go to your timetable and okay. Let me mute your. Okay, I mute all your mic, so I cannot. We do not have the disturb. Okay, so if you want to change your timetable first, or if you want to change your tutorial time, first change your timetable. Please mute your mic, otherwise I got echoes. Okay, okay. I believe you can hear me, right? So if you change your timetable first, if you cannot change your timetable, that means, well, the favorite tutorial group is full, so you cannot change it, right? I feel so that doesn't mean we do not support you, we don't care about you. The system doesn't allow you to change your timetable. Then you'd better stay with your original group, right? So if you can change your timetable, then you'd better tell the new tutor to add you in the Teams channel. So you can find the tutor's information from Canvas. Okay. So if you cannot change it, then you'd better stay with your original tutorial group. That's about tutorial changes. Okay, I think Nippon has a question. Yes, please.
Yes, sir. I haven't changed any tutorial class, but I haven't been added to any teams or anything like that for the tutorial. So I don't know where the tutorial will be happening.
Okay, so you go to the Canvas on the excuse me, I cannot remember exactly. In the discussion board, there is a post. I list all the information about the tutors, which session, who is the tutor, and you can find them, find their email from the Canvas, and then email them. Ask the tutor to change it, because I can do it as well, but sometimes we should keep the tutor in the loop. Otherwise, the tutor will may get confused, right? Okay.
Thank you, sir.
Okay, thank you. Any other questions about the tutorial changes?
When will the tutorial start?
It starts today. If you are postgraduate, immediately after this lecture. If you are undergraduates, that's tomorrow.
Sir,
Thank you, sir.
do we have the pre-class preparation for the tutorial, or we just attend tutorial without any preparation?
Okay, that's I think it's if you have a preparation, it's much better for the tutorial, right? It's active learning rather than okay, I just go there and then well passively join the tutorial. Well, it's up to you, but I do suggest you to have a look before the tutorial, have a look before the lecture. Then if you have questions, maybe you can discuss it deeply.
Oh, okay. Thank you, sir.
Thank you. Okay. If you do not have other questions, then we can keep going because the time is only is really very limited. Okay. The second question I want to discuss is about the textbook. Although our lecture is set in this way, you can read the lecture notes. There is a lot of information, right? But I still strongly suggest you to read the textbook or textbooks, right? So you see, this year we add a new text for you. The second one, Morgan's the Morgan's book, Software Testing. Okay, the Certified Tester Foundation Guide. The book is a very thin book, very logic is very clear. So I think it's quite good for you to read. I believe I enjoyed reading it, so I believe you should be able to enjoy to read this second book. Okay, the first book is a bit old, but you know, software testing is an old topic. So the first book, textbook, is still good, right? Covers more content. Well, if you need more information, more executable plans, details, I suggest you to read the reference number 1, Perry's book. That book is more than 1,000 pages with a lot of details, tables, forms, right? I think if you can treat it as a handbook. Right? So when we study, I believe reading is important. You cannot depend on, well, say, okay, I need sit there passively, wait for someone to feed you. That's not a good way to learn, right? So I do believe go through the lecture notes and also read the textbooks, or at least one textbook or the references is good for you. So at least these 3 books, Black, Morgan, and Perry, they are online, available online. So everyone can read them online. Okay. Okay, that's about the textbook. Do we have any questions?
Hello, sir.
Mm-hmm.
I'm just wondering, like, how do you suggest we read the books? Like, do we like read all of them, or is there any like specific part we need to start from?
Oh, that's a good question. Okay, if I were you, okay, then you do not need to follow what I said. Everyone is different, right? Everyone has his or her own way to learn. But for me, I think if I were you, I will read the Morgan's book first because it's short and covers a lot of content. So, well, I think then you can establish a global view about software testing. But because that book is the pages are very limited, a lot of content not covered, so I think then you can read Black's book, right? If you want more, then you can also read Perry's book. Okay, so there is no way say, okay, you read this, that's enough. I don't think this is a good way to learn. Okay, that's my suggestion. So you definitely you need to go through the lecture notes, which is very close to our assessment tasks, right? The quiz, the 2 quizzes. So there is no specific way to learn. So up to you.
Thank you, sir.
Thank you. Okay, then let's go to the next page. Okay, I want to let you know I'm making recording of every session. You know, the last year I didn't put the live lecture online because I don't want the student to get too much repeated content, right? But okay, this year I will keep the 2 separate sessions about each lecture available. Right, the content was recorded last year, the same for this year. But this year I will put the online lecture available after each lecture. Then you can use, okay, whatever you prefer. Okay. So I disabled your camera. So just I am making recording for each lecture. So let you know. Okay, lecture 2. So last week what we discussed is about an overview, right, of software testing. So software testing is important. Okay, this week we talk about 2 things. Part 1, quality of products, of course, include quality of software, and then part 2, testing. Global view of testing, and then I still have part 3. I will leave some time, maybe 10 minutes or 15 minutes, 20 minutes. I will break all the attendance. I see we have 212 classmates here. So at the end of this 1.5 hours, I will randomly assign you guys to say 20 rooms. Then you can connect with your peers, you discuss about the teaching content. So because of the online learning, a lot of us feel that isolated, right? So I think we should create some visual value for people to exchange ideas about this teaching and learning. Okay, as we discussed last week. Okay, so every lecture 3 parts. Okay, part 1, part 2, and part 3, social or networking, okay, or discussion. Okay. The content of this week is related with part 1 of assignment 1. Assignment 1 includes 2 parts, part 1, part 2. So what we discussed today is related with part 1, static testing. Systems and products. This is a big concept. Usually so I believe most of us has the idea. Okay, what is a system? Well, so a university is a system, right? We have different components, lecturers, students, professional staff, and canteen, right? Security. So that's a system. Well, what is a product? For example, your mobile phone, the iPhone is a product, right? So the definition, you can go to the details. Okay, so any assemblage of, for us, for this subject, any assemblage of computer programs and all manual process, plus equipment, infrastructure, business methods, filing, and so on, is a software system, right? So you, for example, your mobile smartphone, it is include hardware, right? The phone, the smartphone set, software. Well, say you have an operating system for your iPhone. You also have downloaded a lot of apps, right? Is that all? No. You still need the support of networks. For example, the communication networks, right? You also need the support for the internet. So you see, these are the infrastructure. So a system or a product actually not. It is a broadly connected item, right? So when we do software testing, you not only, for example, you test the iPhone operating system, not only the Android operating system itself, but also the hardware, right? Because the testing is related with the hardware. It is also related with the infrastructure, for example, networking, right? And a lot of other things. We always have new products appear from time to time, that's for sure. Okay. Testing, okay. So what is testing? Well, in general, it seems that testing is simple, right? For example, I build a chair, then you always need to test it. Can I sit on the chair? Is it stable, right? If it is someone is 200 kilograms, the weight is 200 kilograms. Can the chair afford that gentleman or not? Right? Those all testing. Okay. So in terms of software testing, it's more complex. In general, we say software is also a product. Right. So when you do testing, you also need to follow a set of rules, say quality control, quality assurance, the detailed testing, right? But also software testing is also different from the traditional manufacture products, right? So sometimes it's quite hard for us to say this software is 100% say bug free. No one can say that, right? Okay, so here you see the testing process is a reliable, repeatable, dependable system of methods and tools that our organization can rely on. Okay, so we match this more with software testing. That means software testing you can repeat. If you find a bug, then if you set the same environment, the same procedure, you should be able to see the bug, right? No matter who executes the testing. And also, testing is not random. We need strategies. We need tools. We need mechanisms for the testing. Okay, and also testing is organization behavior. Right, we have organized people following rules to do the testing. Of course, if you say I develop a simple website, right, to record the customer's contact email address, then that's a very simple logic business, a simple software. The testing is quite simple, right? Maybe you just send a few emails to see if they can receive it or not, right? But sometimes the software products usually in the practice, for example, iPhone, the software for your iPhone, it's quite complex, include a lot of different functions, a lot of different modules, a lot of different users, right? Different environment and so on. So you do need a strategy. You do need an organization, the testing. Okay. Quality. I have to speed up, otherwise Okay, the lecture only give you some outline. Later on, I think you do need to read the notes that I uploaded to Canvas. Okay, and also the textbook. Sometimes some question we didn't cover, you may need also search in the textbooks. Here, what is quality? For us, usually we have some, I believe people usually have some concept about quality. For example, now people say, oh, okay, for example, now in Sydney, a lot of people say, oh, I want the Pfizer vaccine. I don't like the AstraZeneca. But well, that's for me. I think it's, maybe the Pfizer is a little bit better than AZ vaccine, but I believe they are very similar, right? So I just had the second dose of AZ yesterday. Oh, feel nothing happened. Okay, the quality. Okay, so quality you do need a measure. Okay. And also the example I used for the vaccine, sometimes also related with the personal understanding, right? Some people said, oh, everyone said Pfizer is good, so I want Pfizer, the Pfizer vaccine, right? I don't want AstraZeneca because it may cause blood clotting, but you know the probability is very low, right? Okay, anyway, that's I just use it as an example for quality. Okay, doesn't mean I encourage you to make any decision. Okay, okay, thank you. So quality, that means the business strategy. When we make a software, we make it for our customers, so they have their requirement. For example, they want to say, I want to run an online auction software. So can you develop it for me? Then I have this function A, function B, function C. So we need to meet their function, right? At least. And also we need, they have our customers, they may have other requirements. For example, they want the performance, right? They want other items, for example, security, privacy, right? Because auction, then online auction, maybe I don't want to other people to know who I am, right? So we have to meet their business requirement, and also we need a good quality products or service that will satisfy the customer. Okay, this we mentioned. Okay. Quality processes that are consistent and reliable while growing and changing to meet changing needs, especially for software. We know when we develop software to serve people, actually we develop software to serve the management of that company. For example, the banking industry, right? The business is changing from time to time. If the law changed, then you have to change your management. Then we have to change our software. For example, in previous years, okay, so in recent years, the telecommunication company are required to keep the data for 2 years. 10 years ago, we do not have this requirement. So then we have this new business requirement. So the software have to be changed. Then we have to test it, right? Okay, so the management always changing. So the software needs to change and also need to be tested. In the lecture 2 folder, you will find some examples that we list here. So the stock market example. So the software you changed, you have to test it. You do not assume you changed the software, it will work smoothly. You have to change it, have to test it. Otherwise, you may face a big music, right? Please refer to the example. Okay, management. The key point for this slide is management is very, very important for testing. Management is very, very important for software development. Okay, anyway, software testing is a part of software development, right? So management is also important for software testing. Before we started the testing, the whole team, right? Everyone in the team has to be on the same page. What are our customers' expectations about the quality? Right. So what are the rules for this testing or for this software? What are the conditions, tools? What are the procedures? Okay, those everyone in the testing team has to be clear, right? So in order to guarantee the quality. So management is a big part for the software testing. Okay. So software, there is one concept in software development, of course, also in software testing. 30% depends the success of the software project. 30% depends on technology. For example, the database you used, the program language you used, right? The hardware support your software system, and so on. That's only technically, that's a technical part is only 30% for your success. Another 70% depends on the management, right? How do you manage your resource, include manage your team, manage your facility, manage your time, right? To deliver a high quality software or a high quality software testing. So management is important, okay, in software development, of course, in software testing. The first quality principle we mentioned, do you remember last week we discussed, we presented 13 principles, right? So the first one here is testing must focus on delivering a quality outcome to customer or user, right? That's the first principle. That means we have to meet the expectation of our customers or users. Okay. Quality, as we discussed last week, quality depends not only for programmers, not only for software testers, it depends on the whole team, right? From the, you see, from this diagram, you can see from our quality, from our customers, because our customers will tell you that their expectations, their business logic, and so on. Then the executive of our software team, a company, then the management, then the project managers, project leaders, the ICT department, the developers, and the infrastructure, and then testers. So quality is an integrated concept. Okay. For example, the software company executives they have to have a clear requirement about quality of this piece of software. Then for the testers, we have to be clear the quality definition, the quality expectation. Right? You see, between those those the top and the bottom. There in the middle, there's a lot of different parties, so everyone has to be on the same page. Okay. Of course, quality is about money. If you want high quality, you need to invest more resources. If you want to pay less, then you can only get a low quality product. In terms of quality management, as we discussed in the previous slide, has 3 levels. One, the biggest level is quality management. For example, include the customer expectation, the software company executives, project managers, or the executives. Okay, that's the high level. The second level is the quality assurance. The quality assurance then is in the middle of the pyramid, right? For example, project manager, program leader, testing manager, development manager. So it's called a quality assurance system and process that prevent quality failure. The lowest level is quality control, the detection of faults. Okay, so it's here. Okay, so three levels. That's quality. I just due to the time limitation, I just skip it. Okay, questions I will leave for the third part. You guys can discuss about the questions, your ideas in the third section of this lecture. Mistakes. Well, anything made by man is not perfect, right? So any products is not perfect. So of course, software, any piece of software is not perfect either, right? You can see a lot of critical applications failed because of software, not because we want the failure, but because sometimes the bugs, we cannot find them, right? We cannot say this piece of software is 100% bug-free, okay? Because there's a lot of things, even the software is perfect yesterday, but today, because the environment changed, say hardware changed, or the law regulation changed, then the software may have some problems. Okay. So you see every year we pay a lot of money for the poor quality. One example is the cars. I believe some of you may have cars, right? Sometimes you see the car companies, they will recall car back because of this reason, that reason, right? So the global impact of poor quality, you see, how much is it? Okay, you count how many zeros are here. 2 examples, you can find those examples in the lecture, week 2 lecture folder. Top 3 reasons failure happened. Well, we accept that failure is possible, right? So failure-free is absolute failure-free is impossible. So then what are the top 3 reasons? First one is lack of planning, scheduling resources and activity. You see nothing personal. You see the government, a lot of government projects always delay, right? So even you have a very careful plan, then you still have some something unexpected. So even you have a very careful plan, those kind of big projects always have delays. Okay, cannot. I believe majority of them cannot be completed on time. Right? If you do not plan it carefully, you can imagine what will happen. Right? Second reason is bad communication, poor understanding. That, well, this, you see, when we develop the software, when we talk about software, our customer is from different industry, banking industry, telecommunication industry, medical industry. They want a piece of software. They will tell you, I want this function, that function, this function. Sometimes they use their terms. They in their, for example, banking industry environment, they understand it perfectly. But for us, we need to understand what do they mean, right? So sometimes the communication has some problems, or sometimes we do not understand what they want correctly. So then we develop the software. At the very beginning, there is a problem, right? So the second reason is bad communication or poor understanding. The third reason is little or no quality control. Quality control, for example, from the programmers, from the developers, why we have not enough control or enough quality control. One reason is sometimes we do not have sufficient resource. For example, the customer said, I want this software will be in place, say, in 6 months. Then in order to catch the deadline, sometimes we work overtime, okay, or sometimes we do not have sufficient time to do it, or we do not have sufficient people to do it, or sometimes we do not have sufficient high quality people to do it. Okay, so that's the reality, right? Okay, I think that's the part one. Let's do this way. I will let's take 5 minutes break. We will talk about part two. Okay, so now is 3. We come back at 3:45. 7 minutes break. Then we discuss about the part two. Everyone can has a short break. Okay, so online teaching and learning is not easy. Okay, anyway, we resume at 4:45. Thank you. Okay, everyone, welcome back. I think sometimes a short break is good, right? Okay. Okay, let's continue our second part for today about testing. All this material, you can also access it in the Canvas lecture 2 folder. I separate part 1, part 2 with my recording, which I did last year. I leave it there, right? So if you want to be use them flexible, then do it. After this lecture, I will also put the hyperlink of this recording on Canvas, so you can also use it. Whatever you like. Okay. Testing part 2. Sorry, I mute myself. Okay, testing. Hang on. Let me see. Okay, about testing. If you read our textbook or the notes, you will find that the first thing we need to do is for testing is to decide the scope, right? So for a product, a software product, testing could be big, it could be big or could be small, right? Depends on what do you want, what the customer wants. So item 1, every test must have a clear defined scope, right? So for software testing, you see, for example, the software in our smartphone. So you only test the application, or you test the application and also the Android operating system, or you test how the software plus hardware, right? Or you can extend, say, test the mobile phone in the connected with the communication network, the mobile phone's performance or problems with internet accessing. So that's the first. When you do testing, you need to be clear about the scope. Once that's the target. Once the target is clear, then you know what do you want us to test, right? So different range, different scope, then you definitely test different things. Then you can decide how long do we need, how many testers do we need, what kind of testers do we need, right? And what kind of facilities, what kind of software, what kind of hardware do we need to deliver this testing? Okay. That's the scope. Second principle for this subject, quality principle. The sooner bugs are found, the cheaper they are to fix. So if you read our Morgan's textbook, he gives a clear quantity about this. So if you find a bug at the early stage, it costs $1. Second stage, $10. Third stage, $100. Fourth stage of the life cycle of software, $1,000. Anyway, if you find it earlier, the cheaper. Otherwise, every time, one stage later, 10 times more in terms of cost. So you need to find the bugs as early as possible. In this world, we also heard some strange things, right? Someone built a high building. When the building is done, they notice that there is no lift, right? Okay, this kind of things happens. Okay, so we need to find the bugs as early as possible. That's principle. So the first stage called static testing. You do not build the device and then test it. At this stage, it's too late, right? So static testing. What is static testing? That means, or we have definitions in the next notes and also the books. Or make it simple. You test based on paper rather than you build the software. The software is built and then you test it. That's called a dynamic test. That's too late. Okay, too costly. So in this subject, all the assessment we do is static testing. When you have the software in place, you test it. That's called a dynamic test. It is too late, too costly to fix the problems. Okay. So how to do the static testing? This involves the life cycle of software development. So I do suggest you at least complete the reading of the chapter 1, introduction of the textbooks, okay, or one of them. Okay. The requirement first one is what they say they want. That means when you develop a software or when you test a software, you need to know what our customers want, right? Second, how the business functions. So we are software engineers, we are programmers. We are good at programming, but we do not understand how to run a bank business, right? How do telecommunication, how do they run their business? We don't know how the doctors, they run their business. So we need to understand how the business functions and also the externals. For example, you run an online auction business. Someone asks us to develop an online auction business for them. So they tell us the function, this and function 1, 2, 3, right? For example, but also there is a lot of other knowledge. Maybe our customers, they are not clear. Say for the online auction, for that business, there may be some regulations, legal requirement. Sometimes they don't know, or sometimes the new requirement, the customers, they are not clear. Okay, so this is called externals. So all these are the requirements, right? So when you do the testing, you see, you can have, if you want to do how to say, exhaustive testing, then include a long list. Okay, static testing. Each requirement must be complete, unambiguous, right? Complete, that means it must address all potential situations. So sometimes you go to because I worked in the industry, right? For example, I did the billing system for telecommunication companies. So sometimes they said, okay, in our business, we have this function, we have function A, B, C, D, E, F, G. But after a few months, they may tell you, sorry, I forgot to tell you, we have another function, right? Okay, so when you do the requirement, you'd better make it as complete as possible. Sometimes there's maybe new changes, right? So you see, the complete sometimes is not easy. Unambiguous, it must be clear and precise. Sometimes, well, for example, in the business, everyone knows that term. What does that mean? For example, say business time. So, but you have to declare it, be clear, very clear about it. What do you mean? Normal business time. It is from 8 a.m. to 5 p.m. or 9 a.m. to 5 p.m. right? So in their company, then maybe everyone knows, but for us, it's not clear. So you have to make clear definition about terms, consistent. It must be the same throughout all documents. Sometimes when you do the business analysis, you may talk with different people from your business partner. They may use different terms, right? So someone from the marketing department or someone from the operation department, they may use different terms. For the same business, they may have different explanation. So as a software developer, as a software tester, we have to make it clear, or make it consistent, okay. Testable, it must be measurable, able to be carried out, and repeatable. Sometimes something we may be hard to measure. For example, we develop this software to make sure our customers are satisfied. What do you mean satisfied, right? So this cannot be tested. So you have to be clear, right? So for example, the functions, what are the functions, right? What the performance they expected. For example, the online option, they want the response time is less than 0.1 second, for example, right? So if the customer said, okay, we want the response from our participants is good enough, this is good enough is not testable, right? You have to make sure it's, for example, less than 1 second or less than one day, right? That's called testable. Feasible. It must be possible within budget, time, and capability. Feasibility is an important thing. Why but if not most of the time, sometimes we always lack of budget. The budget is always not enough. When we talk about budget, include time, people, and other resources, right? So it's not always enough. For example, we have in you guys' case, the assignment. Everyone has 2 subjects. Well, a lot of assignments. The time is not always a problem, right? Not always not enough. Okay, so you have to in this situation, in terms of software testing, then we have to make our decision, right? So we have, for example, we have to test the most important part first, right? We have a list with priority. Then the less important items may be ignored. Then this is a potential problem with the software, right? Because you didn't test it, you cannot guarantee it will run smoothly. Maybe there are some bugs there, right? Because you do not have enough time. So, okay, feasibility. The important thing of static testing is to get past what is being asked for and to understand what is really wanted. Okay. This is not only involve techniques, but also involve management.
Sorry.
Sorry, any questions?
Oh yeah, sorry, just a quick question. It seems like for static testing, from what I've looked at another time, is there any like techniques we're going to be going through to help sort of understand what a client might want out of a software? Because it seems like you need just a lot of experience more than anything else for to see what to get through the thing. I'm not fully sure because.
Okay, of course, that's a very good question, right? So this subject is part of software engineering. In terms of software engineering, it's a set of skills, how to do the business. There is a how to do the business analysis. We will cover this part later on. Of course, we have rules, strategies, not only the experience. Right? Of course, experience is important, but the rules, the tools, the strategies, well, all these are discussed in software engineering. Okay, so don't worry, we will touch that part.
Thank you.
Yeah, thank you. Okay, as we mentioned, static testing is the process of reading all supporting document for the system. So static testing is a test based on paper. When we do static testing, the product is on paper, not the software not started yet, right? We have no code at this point. Then we do the static testing. Then, okay, what we will read and test, consider the documents. What are the documents? The business cases, user requirement, business process document, system architecture, program specification, and anything else that's pertinent. So before we coding, we do a lot of paperwork. So in terms of software development, software development is not only about coding. Okay, someone said, okay, as a programmer, I'm good at, say, the Python language. It seems that I'm qualified to be a developer. I don't think so, right? Roughly, for a software project, the coding part is only 20% in terms of time. So if a software development need 100 time unit, programming only 20%, right? So other 80%, what are we doing? We are doing this business analysis, user requirement. We do a lot of this kind of paperwork, or you say documentation. So the programming is only a small part. Coding is only a small part of the life cycle of a software project. Okay, this is a static test example. Okay, so of course there are a lot of tools we can use, but of course this tools is not free. So as a teaching learning, we do not have those professional tools. Later on, when you working in the company, they may have, right? But the essential things is the same, right? Tools only help you to make things go faster, smoother, right? So when we use Excel, it's the same thing. Okay, so you see in this example, static test. So you see we try, when we do the testing, we write down the test domain. So it's system functionality, right? Defect description. This, okay, what's the problem? You write it down, because sometimes the tester write down this, later on we'll give this Excel file back to the development team. They will, okay, try to repeat try to see what's the problem, right? Okay, if you say, okay, if I do this step 1, step 2, step 3, then I found this problem, then the development team will repeat your steps, try to see, okay, it is this problem appears, then they may fix it, right? Of course, when you talk about the defect, so which file So in, as you can see in the previous slides, we have a software development. We have a lot of documents, say business analysis, system design, software design, infrastructure design. So this static test is against this defect is against which document. So you have to mention it clearly. For that document, which page, even which paragraph, which line, right? In this way, can make the reader or the developer, the programmer, easier to locate the position. In this case, you see we have the server 0 and then the path and then the document name, right? So usually in a software company, when maybe we have a number of servers, right? For example, when we develop a database, we have a database server, and also we have say a file server. So in the file server, all the development, the software development files are there. Business analysis, system design, say function design, program detail, program design, all in the file. You see, in this case, the / server 01 means a specific server, right? Of course, it could be any name, right? This, if you're familiar with Microsoft local area network, Microsoft server, okay, they usually use this kind of way to identify this is a computer in a local network. The computer is called server 01, right? In that file server, we have, say, new projects, a folder, and then new e-commerce system, it's a subfolder, right? Then this is a business requirement, version 1.01.doc. Okay, so this is tells the reader which file we are talking about, which page, which paragraph, or even which line, right? So then in assignment 1, part 1, we will do this, okay, static test. Functions, we say software or any product, we have functions, right? For example, your mobile phone, smartphone, you have a lot of functions, right? So for the software, we have, you see, so many functions. So when you do the testing, I think you may, against this table to check the system functions, user interface, right? Transaction processing, data quality. So those are the functions. Some functions are, for example, environment, right? Say power and heat. Well, that's or infrastructure. Okay, so I believe this list is the function, system function, latitude is the most important, and then the priority decreases. Okay. Okay. Some, you see the user interface at the early stage, we do not have the software, but we do have designs, right? In this user interface, we have this button, that button, right? For example, someone want to pay online. Someone say, okay, I will maybe pay, use credit card. Someone may pay, use some other ways, right? So you do need the user interface design. Even the software is not in place, but you can still check it. Okay. Testing is, okay, so the means by which a product is compared to the expected level of quality at every step of the production process. So anyway, testing is to make sure our software meets the customer requirement. Okay. It is not an isolated process. We say, excuse me, testing actually is in the every step in the life cycle of a software. Right? Testing need carefully planned. Right? Failed to plan is ensures failure. Right? So if you do not, even you plan carefully, you cannot guarantee there is no bugs, no failures. If you do not plan carefully, you can imagine what will happen, right? Testing is more than finding bugs. Okay, finding bugs is a goal of the testing, but testing is more importantly to improve the quality of the product. Okay, so the questions, I leave it to section 3 for you guys to do. Okay, that's a tutorial. So once again, for this week's tutorial, we cover the content of last week. So the tutorial preparation is, you please go through it. The content will be covered in next week. Okay, all the tutorial materials are online. Right. Okay, this is part 2. Thank you for your time. Let's do this way. That's my plan. We still have, say, if you take 5 minutes break, or you or not. Any questions from anyone? Hang on.
Sir,
Yes, please.
I do have a question, but it's not related to the subject content, today's content. I just sent you an email about the conflation with another subject I mentioned last week. Could you please have a look later and replying back to me, because the census date is drawing near. Yeah.
Okay. Okay.
I
will check my email, because sometimes, every day got too many emails. I will check it.
I know that. Yeah, I just sent it because I was in another class. Yeah.
Okay. Okay.
I've already contacted the student center, but I have no hard back from them, so I don't know what to do now. That's why.
Okay. Okay. There are some questions I don't know how to answer. For example, someone said, say, I have 2 lectures at the same time. Say, can I absent from your lecture and to attend another one? So this kind of question, I don't know how to answer, right? So sometimes.
Yeah, I know that. Yeah.
Okay. 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 Thank you for a question.
I have a question here.
Mm-hmm.
For the tutorial preparation, it says that to watch the static test video. Where can I find this video?
I think the video should be in the folder of the week 2.
I already checked, but I couldn't find it.
Okay, I will check the video for week 2. Okay.
Thank you.
Thank you, Walter. Okay, let's do this way, guys. I will create the rooms. Say let me see how many people are here. 194. I will create 20 rooms. So randomly 10 people will be in one room. Then you can use the 15 minutes to discuss the learning or networking. It's up to you. If you have good output from the discussion, please post it on the discussion board on Canvas. Is that okay? Guys. Okay. Okay. Thank you for the feedback. Okay, I will do this way. I will stop the recording and then create the rooms. Then you guys will be randomly assigned to the rooms. Then you can say hello to each other and discuss whatever you want. Okay. Thank you very much.